In this video, we're going to talk about the data definition language, which is part of the SQL language, and that part that is designed for sort of creating the database. And we're going to focus here on the sort of an attribute and the attribute's name, its type, its domain, and so on. Okay, so we're in the data definition language. Again, SQL, the main language of databases, has many different implementations depending on like what system you're using, but it is overall the main language for almost all of them. And it's broken into three main components: the data definition language, where you create a database. That's the subject of this video. The data manipulation language. Once you've created a database and you're working with it, you use the data manipulation language. And the data control language that determines like what user of the database can have access to what information, to what data. So this is the data definition language. We're going to create the tables, say what the variables are going to be, the columns, the attributes, the properties, whatever you want to call that. But we're going to gather together them and then sort of make a table and then say how tables are related and so on. Okay, so we're going to start with the smallest unit, and that we'll call the attribute. But again, there are other words for it. Column, when you in a database, we're going to sort of think of things as a relation or a table, and so we'll think of rows and columns, and so we think of the attributes as sort of all lining up in a column in the table. So that's another common word for it: property, attribute, column. And so it's the first thing we want to do is then give it a name, give it an identifier. And so in this just example here, we're just showing you that other things, like in this case, an HTML element also has attributes. So those things that are in tags in HTML, uh, between in HTML tags, are also known as attributes, and they have names and values, or uh, keys and values is another common term. So we're going to start off with the name. So, so would be like in the previous example of href being an attribute, that is sort of a predefined identifier, a predefined name that has a particular uh, role. But here, when you're creating a database in the data definition language, you're going to be defining your own properties, your own attributes. And so we're going to start off with a name to identify that property. And there are some strict rules and then a lot of implementations of SQL sort of lighten up on some of the rules. But let's go with the strictest rules. It should be uh, characters from a particular set. And so that's capital letters and small letters and numbers and an underscore. So it really shouldn't have a space. Um, we can have letters, numbers, and underscore, but it ought to start with a letter. And it shouldn't be longer than 128. I don't think it should even be that long. That's pretty long of a name. Um, but you'll find, like, especially like spaces and things like that, in the strictest sense, not allowed, but a lot of implementations will allow it. And then you will find, if you've seen some SQL, especially, you will see like names of things which will be part of what we call the metadata will be in tick marks, whereas data will be in quotes. And if you keep to the strictest sense the names and don't have spaces and things like that in it, then you don't need the tick marks. If you're sometimes you're working in a system and the system will put tick marks everywhere, and sometimes you can get rid of the tick marks. Sometimes you need them. If you have like a space in the name, you're definitely going to need those tick marks. So I would just avoid the spaces in the name, so I wouldn't need the tick marks. It's nice that the system's providing them, but if you have to provide them, then it's a bit of a pain. So some one of the next things that one does with when defining an attribute is to give it a type. So there are a number of standard types in SQL. Um, a Boolean is something that's true or false. Sometimes you'll just have some languages will just say text, but some languages will specify between char, character, and varchar. You can have an individual bit, various types of numbers, dates, timestamp, um, and these sort of binary large objects are also known as blobs. Say if you wanted to have sort of pictures, some large sort of larger thing defined somewhere, stored somewhere in your database. Okay, go over some of them one by one. Boolean is something that's true or false. So one of my sort of databases I tend to talk about is like a database for the Simpsons TV show. And then you have real people who like voice characters, and some of them are are the regular characters that appear all the time. So these are people who are sort of always working for The Simpsons, and then you have guest stars. So there might be a, a an attribute that says whether they are a regular or a guest star. So that would be a Boolean, true they're a regular or false. And then just a sort of standard thing in databases. So we usually say a Boolean is true or false, but databases also tend to support a null value, sort of, so that you can just sort of like an I don't know one way or the other. So in some sense, if you're going to allow a null, then the Boolean can take on three values, true, false, and then null. Next up is char and varchar. So say what I've been working in lately is SQLite, and you usually just end up saying text, but other SQL languages will make a distinction between char and varchar. So these are for some kind of text, typically letters, but they can also be other characters. Um, and char is for when you have like some exact length. So like if you have like a string ID, an ID that's not an integer ID, but some code that you use to identify a product or something. Um, then those will tend to all be of the same length, and then you might use char and specify its length. If you say varchar, and then you give a number, it's sort of up to that length. So with char, you're giving an exact length. With varchar, you're sort of giving a maximum length. So people's names, some people have short last names, some people have long last names, and same for first names. And so that would tend to be varchar. Now we'll get over into the numbers. Integer are like numbers with whole numbers. They can be positive or negative. Some systems will allow just to save on space a bit, uh, an integer that takes up less space than a sort of a normal integer, and that would be a small int. So if you had something, if you had populations of states, then that's going to be up in some millions, and so you need fairly big integers there. But if you're doing room numbers or something like that, then you might just treat a room number like it was like a string, like text, because it's you're not going to really work with those room numbers as numbers. But if you were to treat them as numbers, or if you had other numbers for some reason are going to be small, then you might use a small int if it's available in the implementation of SQL that you're working with. If your number has a fractional part, then you have to pick a type that allows for the fractional type. And so there's one is numeric and decimal. So again, I've been working lately mostly in SQLite, and it supports numeric. Um, and then in when you declare something, and these are numbers with, again, fractional parts. They can have a whole number and a quote unquote decimal part. Um, in when you're declaring something as decimal, you're saying how many numbers sort of all together and how many numbers sort of after the decimal place, and that is useful for sort of knowing quite precisely the precision of the number. So if you're going to be working with money and you want to deal with cents, but you don't have to want to worry about, fractions of a penny, then you might sort of use a decimal, and then you'll know the precision. Um, Numerical is similar to uh, decimal, but just it's a little bit stricter. That so one might go a little, allow a little like wiggle room at the end. Um, so like you need under the hood, everything is sort of bits, and one it will be a little bit stricter with the limits than the other, but they serve a fairly similar purpose. If you have really big numbers, then you want what's called a float or a real. This is the sort of uh, programming or binary version of scientific notation. So if you had numbers that were going to get extremely large and extremely small, then you might choose this type. I don't know that I've ever, if I guess if I had scientific things in a database, then you might want such things, but I don't know that I've ever seen a float or real um, in a database. Um, but a more important practical thing to have in a database, especially a transactional database, is the date and time. You've got to be a little bit careful with dates if you're keeping things and dates that are really, really old. It can be a problem. So I've had examples where I've had sort of, I don't know, like impressionist painters or something like that. And some of those dates from the 1800 were sort of difficult to store in a database. But if you're sort of doing sort of, more modern, more up to date dates and times, uh, then that's a reasonable way. And then the system knows that what you're putting in there is a date and will help you sort of deal with it as a date and save you some sort of parsing months and days and years or what have you. Okay. The next idea that we're coming along to is the idea of a domain. So the attributes type sort of says what kind of values it can take on, but you might want even within the type to narrow it down a little bit more, and then we're bringing in the idea of a domain. So you might restrict the number, then it must, if you have a number, then it must be greater than something or less than something else, some kind of uh, range of values, a range of allowed values, or you might, in the case of uh, text or something like that, you might provide an exact set of values that it can take on. So if you had some kind of level, you might say beginner, intermediate, expert, or something like that, and then those are the three allowed values. So in both cases, whether you're doing, between these two numbers or from this set of strings, you are working with the domain of the attribute. And this was mentioned previously in the case of the Boolean, but here it is again. It's an important concept in databases. Goes back to COD, that you should have allow the database should allow a a a null, that to say I don't have a value for that. And null is different than zero for a number. It is different from an empty string in the case of text. And it's just saying I don't have that information that is different than it's zero. I don't know the balance is different than a balance of zero. Um, and then within SQL, like you want to be able to control. So the database allows, in principle, the database allows nulls. But then when you are defining your attribute, your property, you will like further specify, I will allow this value to take this property to take on a null, right? Or I will not. And so that is, and the default is that because it's a database and the database are supposed to support nulls, the sort of default is null is allowed, but you can say when defining an attribute not null for this property, I'm not going to allow it to be null. So again, so null is the default, but you can strictly say that it can be null, although that's again the default, so that would do happen anyway. More important if you want to say that it's not null. So if you want to have uh, some ID. Now, eventually, after we define our attributes, then we will start to get into tables and talk about the attribute having a role in a table, and it might have the role of a primary key. And then there are certain things like not null is sort of implied by being a primary key. But uh, even if something's not the primary key, we can specify that it's not null. So if we specify something as the primary key, then it's implied to be not null. But and even if it's part of a composite key, it's implied that it's not null. But we can specify this for other properties that they are not allowed to be null. Um, and then SQL supports this keyword check. So we're now going to insert data, and then we want to know, does it obey our domain constraints? So we had our conditions. We said that the value should belong to this domain, and then we can check, does it have these, does it obey our rules? Is the job back to in my simple little Simpsons database, I had like actors and producers. So is the job position from that list? Or is it a null? Did I, so I allowed actor, producer, or null. So I'm checking, is it in that list? Um, is my wage more than minimum wage? So I can put, uh, if somebody does some updating, inputs a wage, I will do a check to make sure it, fits in the domain that I am defining. Um, so here's just an example. So we have the keyword um, domain. So we can make our own. So we're sort of defining our own type. So um, so I can sort of uh, de define. I'm creating a domain, so I can say create domain job type as, and then check that it's in this set of things, and then I can effectively, I'm using the domain to create sort of my own type and then making an attribute of that type. So that's sort of how that works. Okay. And then another thing you can do with our values here is define them a default. So if you are I'm inserting some of it, ultimately some record, but there'll be some attribute within that record. And if that attribute has a default, and if I have not specified the value within my insert, it will take on the default value if I have indeed given it a default value. So if I'm defining levels, I'm defining a new type of levels, so the level type, and I can say belong, I'm allowing beginner, intermediate, and advanced, and then I'm saying the default is beginner. So if I specify, it will take on the value that I specify, provided it belongs to beginner, intermediate, or advanced. But if I don't say anything, sort of instead of being null, it'll take on the value of beginner. So that's sort of purpose or what is the result of having a default. And that's it for this one. Next time we'll move on to bringing all these attributes together and making records and tables and so on. Thanks for your attention.